Hi, today on the garage bench I have an IBM PC 5150 that a friend asked me to take a look at for him. He found it in the back of his garage after a massive clean out, and it had been sitting there for years, I'm going to say probably decades. Now it is absolutely caked in garage grit, so there's sawdust, there's dirt, there's some drips of something, cobwebs, lots of stuff, and that is incidentally why we're in the garage before I take it into the house. So let's dive into it, take a look, clean it up, and see what we see. Okay, so we're at the back here, and I'm going to start by taking off these 5 screws, which appears to be holding on the top case. Okay, now I think this will just slide forward. No, it does appear to slide back. No, obviously, because it needs to. Okay, so let's have a look at the front. Let's see. We're getting held up on something. The screws on the bottom? No. Just needed a bit of vigor, so let's get that off. Okay, let's take our first look inside, shall we? So, we have a lot of sawdust down the sides. We've got, looks like 4 expansion cards. So we have, this appears to be a RAM card, that's interesting. RAM and real-time clock. Might be an upgrade card of some kind. That on the back would be our, I think it's parallel and CGA graphics adapter. I'll have to dig that out. And then we have the hard drive card here. There's a marking there. Can't quite get it. Okay, we'll have to take that out in a bit. And we have another card of some variety. That would be our floppy adapter. Yes. Cool. And then there's the main board down there. Some AMD parts. A whole bunch of RAM as well. Which you can get down there. Focus. There we go. Very interesting. We'll have to take a look, but it is pretty dusty in here. There's lots of some more sawdust down the side there, but I think let's start. Oh, actually, let's check out that hard drive as well. Look at that boy. To flip the media here, but computer memories Inc. God, look at all the sawdust down there near the switch. So I think with the hard drive, these needed a upgraded power supply. So I think that will be the bigger unit from this original one. Okay, so I'm gonna set you up in the camera again, in the tripod, and let's start taking some of these cards out and seeing what we've got here. Okay. Like I said, I think this is the CGA card. I would have to look it up, but there it is. Black and white and parallel. So yeah, this is actually it's a monochrome card and parallel port. So there you go. Again, I don't know much about this, so I'll probably flash a little bit up on the screen with some more info. We'll check it out in a little bit. But this looks like, like I said, I think that's an expansion card of some sort. I can see battery there, which usually indicates there's a real-time clock on board. So we'll see what we've got. There is a lot of memory on here, so that is a memory expansion of some kind. Yeah, like I said, there is a clock battery here, just a gob of RAM. So these are 4 and 6 4s. There are 1, 2, 3, 4, 5, 6 rows. And there's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that'd be, it's actually a different one on the bottom there. Oh no, they're 4 and 6 4s. A lot of tantalums on here as well. It's this WD8250PL. Yeah, I really don't know what this card is, but other than being memory and real-time clock, that one there, the B8532. So Yeah, I'll have to look that one up. Okay, moving on. Okay, then we have, I think this is the hard drive controller, which is interesting because it's not plugged into a slot that has, or it's at least missing the plastic holder, so I might be able to 3D print another one of those to get that back in and solid. So it is a Xebec. Xebec. Indeed, it does look like a hard drive controller, considering it had the hard drive plugged in. This is the component side. It's interesting. And lastly, we have the floppy cable. So that's on floppy. And get that guy out. What do we have? This is very sawdusty. We've got a D765AC. That's a floppy controller. Pretty standard one of the era. Yeah, it just looks like a generic floppy controller. It doesn't look like an IBM specific one. I don't see a fab number. Yeah. Okay. We're already seeing some MT RAM on the board here as well, which signals trouble. Yeah. There's our CPU, the P8088. Some memory controllers over here. That's an 8255AC. 8237AC, I'm not sure what that one is. Here's our ROMs. Looks like we have the full complement. And lots of sawdust. Sticker. Oh, there you go. That's our upgraded. Yeah, that is an upgraded power supply. So if it's 130 watt, I think the stock was something like 60 to 80 watts. So if this is a 130, obviously 220 because this is Australia. But if this is a 130 watt power supply, that has definitely been upgraded over the stock. And again, I can see some tantalums down here, which will need testing and or just a straight out replacing because they like to explode. Alrighty, let's take... Well, first of all, I need to do this. That was fun. 64 to 256K. 644, what do those say? 644 9018 XM. 6135712. Yeah, I'm not sure. But yep, there is again our Intel 8088 CPU. Beautiful. So no math coprocessor installed in this at the moment. See if we can work on that later. Although there are some, these are genuine IBM ROMs. Like that one's an IBM Corp marked, so's that one. This one too. Yeah, these are all genuine IBM ROMs. I think at this point I'm going to try to get the hard drive out. Let's pop the main board off to the side safely. Probably the left to do is the, like I said, the hard drive, which has a couple of screws on this side, and then it should just slide out as well. And then the power supply, and then we can give this case a full clean. I'm going to take everything outside. I'm going to do that off camera for now, because you've seen me take apart enough. And then we can take a look and I'll do some research on these parts, see what everything is, and go from there. So I just took the power supply out, and while I was moving it about, I heard something rattling inside, so I gave it a bit more of a rattle, and these fell out, which, if I align them correctly, you can see were shards from a capacitor inside. This is probably one of the 0.1 microfarad. This will be one of the oh no, this is actually two. This is two of the same kind. Wow. So there are some, I'm guessing there's a class X or class Y, and they would have exploded inside. So I will not be plugging this in, which I was wise to not do, and instead I will be pulling this apart and finding out what needs replacing and doing that quick smart. So yeah, let's dive straight into this. Cool, so we've moved the action inside, and I've got the power supply because that's the first thing that we want to take a look at. If we can't get good power to the main board, we can't get the main board going. So I've got the main, let's have a look at the main board inside the power supply first of all, and it seems fine. So gave it a really good clean, got rid of all the scunge and dirt and sawdust and whatnot out of there. And like all of these capacitors, you know, ignoring their age, they are relatively high quality parts, a lot of Nichicons and stuff like that, and none of them have any signs of leakage or
bulging. So the tops of all these caps are not bulging. So I am going to leave well enough alone inside here, and we'll see how we go when we get to that point. What I do need to do though, and this is what we saw earlier, which is in the other like the chassis here, is these caps here have obviously lost their shell, and that must have been some event. I don't know. But what I want to do is just replace these. These are the main input filtering, and I've got some replacements. So these are X2 class, and obviously they're a little bit smaller, but they are the exact same rating. They are 104K, which is 100 nanofarad or 0.1 microfarad, which matches what I could find from the leftover bits that I could piece together, jigsaw them back together, and they are rated for 275 volts just the same. So what I'll do is take these out really quickly and then pop these in their place and see how we go. Now I am going to have to bend the leads a little bit like that and then down a bit just to make them fit. And I'm probably just going to do this in situ because I'd have to take... It's just a bit of a pain getting this little subboard out, so yeah, I'll just do it like that. And I'll just take these out through the bottom here. It's only 4 solder joints. Should be relatively easy. So yeah, let's dive in. Piece of cake. So while we've got these out, let's see if we can test them. Maybe they are actually fine. That's not gonna work. Yeah, let's do it this way. Okay, so I've got a couple of long leads. One run there, one to here, and then on the other side, I'm just going to grab my little tub of off-cut legs. Just grab 2 of those, 1 and 2, and shove those in the tester. Now, the leads will introduce some extra whatever, but it's fine. Okay, see what we see. No part. Let's try it just in case. Different spot. Now I am going between 2 here and 1 over here, so just so the pins properly line up. But yeah, that doesn't actually read, so pretty sure that one's dead. I'm not even going to bother testing the other one. Let's just move on. Now, it does look like there are 2 sets of holes. So the ones that these went into are the wide ones, and there's 2 smaller ones there, which almost fit these. So I'm going to use those instead, because it means I have to bend these legs not nearly as much. Just probably do that. Yeah, it's simple. Bend those legs over, and grab some solder, and done. Too easy. Alright, and we'll do the other one. The other thing I want to do is this power supply, and the IBM ones of this era as well, most power supplies of this era, I know the one out of the Compact Portable does it as well, is if they don't have a load, they will not turn on. So what I will be doing, I won't be plugging the main board in through the AT power here, but we do have a couple of regular Molex connectors. So what I think I might do is just pop a hard drive in here, and that should provide enough of a load in order to get both the 5 and the 12 volt circuits activated and happy to spin up. And I do have a spare Connor drive, so let's get this plugged in. Now just for a little bit of extra caution, I will be running this through this is a inline circuit breaker, so it gives me the ability to pop the circuit here instead of popping my entire house circuit. So let me run some leads and we'll get back in a second. Well away from the sparky bits. Alright, that was good. Had a little bit of a zap, but nothing popped, and the circuit breaker is still on. Let's hit power and see what we get. Nada. Okay. So we still have something wrong. Oh, of course, I forgot to plug this in, so just to be safe, unplug. There we go. Now let's give it a shot. Alright. Okay, safe. Let's see what happens again. Oh, something popped immediately. Didn't pop the circuit breaker though. Let's give it another shot. No. How interesting. So it's not shorted or anything. It sounds like this relay triggers, and then nothing happens. So maybe we have something else is dead in here. I see. Okay. Maybe this is not enough load, this hard drive, to get it going. Let's see if we've got 5 volts. Oh, we've got... Oh, we had 5. We had a bit of voltage for a second there, and then it went into protect. So maybe, yeah, this might not actually be enough to start it up. Maybe it needs power good on one of these. Interesting. Okay. Alright, let's have another think about this, and I'll be back in a moment. Alright, so after a good bit of research, I have discovered that this power supply is, or is at least a clone of, the IBM 5155 power supply. So this is a 114 watt power supply out of the 5155. And that means that I can refer to this guide, which I love a good hard copy, was created by Dr. H. Holden, I think it's Hugo Holden, and it is a full, like a full reverse engineer of the entire circuit. It goes into the switch mode design operation. It's got a full diagram which matches the board that we have here. It has individual circuit diagrams and breakdowns for the different, there's the inrush current limiter. This is absolutely fantastic for this kind of thing. Main board circuitry, look at that. And it even has photos of oscilloscope to show what the different parts of the waveform of the switch mode should be doing. But what we're really looking at, and what I'm set up here for, is checking at the back here, the voltage window checking. So what it does is it takes in the 5 volts to 12 volts, the -5 and the -12, makes sure that they're within the right window, and if not, it triggers this V shutdown line, which turns off the SCRs and, well, yeah, there you go. Output is circuit, V shutdown, triggers the SCR on the current shutdown board, previously described, which is one of these ones back here. Now, what is interesting is there's a section here, because I quickly had a scan through this entire board. Where was it? It was right here. This is the interesting part. While I was looking at the board design, trying to figure out where lines go and everything, I read this sentence which says, 12 volt rail in this unit is preloaded by power resistor R7 24R on the main board, giving a 6 watt load. Therefore, the 12 volt supply does not require an additional load to ensure the power supply starts normally. If there is no load on the 5 volt output, or it is underloaded, the voltage overshoot at startup trips off the over voltage window monitor, and the supply shuts down immediately at turn on. Now, I was testing with hard drives, which typically don't use much 5 volts. So, what I have instead is a couple of 1 ohm, 10 watt wire wound resistors. And what I want to do is, now I've got this set up to monitor the 12 volts on the output board. That's the 12 volts that goes into that over voltage window board. And I'm going to be plugging this 20 watt 1 ohm load. So that's popping 20 watts directly on the 5 volt rail, like so. Just straight into ground and red, which is 5 volts. So that will put a 20 watt load directly on the 5 volt rail. And now, let's see how it goes. So I just need to make sure everything is safe, or as safe as I can make it. The meter's on. We don't have power, so let's click on power. Okay, we are live. And let's hit switch and see what happens. And there's our 12 volts. Yes. So, perfect. That means I was just doing the wrong test methodology. I needed to load up the 5-volt rail. Great. Okay, now just as a quick double check, let me grab one of those hard drives. I've got another one here. I don't know where I put the Connor one, but I've got a little Fujitsu one here. So let's grab the other connector, other Molex, and plug that hard drive in. And let's see if we get spin up. Yeah, there you go. Perfect. So what I'll do is I'll just pop this off to the side. And now I just want to double check that all of the other voltages, so the minus and plus 12, are also good. So let's do that. If we go back to the page at the end here, it shows us those connections. We should be able to find minus 5 on pin 5, which is up here somewhere, and minus 12 on pin 6. So let's find those really quickly. Beautiful. Minus 5. Pretty accurate. Perfect. So, I'm going to call this power supply good. And let's move on. I'll put it all back together. And we should be fine to proceed to looking at the mainboard. I was mistaken earlier when I said this was a clone. It is absolutely not. This is a genuine IBM. It is the 6449018 part number. I've only ever seen these in the it's like a brown and yellow tinge. I've never actually seen one in green before, so that's actually kind of cool. Must be common. I'm not an expert on IBM by any stretch of the imagination, so it's entirely possible that these are the more common ones. I just hadn't seen them. Anyway, but it is a 64 to 256K board, and it is absolutely loaded out, which is pretty cool. It does have a crap ton of that MT 4264 RAM though, so we do want to be cautious. And it does have that exploded tantalum that we saw earlier, and a little scorch mark on the AT supply. But let's check it out. So let's see if that tant has exploded short or if it is open. So we want to check the power rails up here. So let's look for, and now we're looking for, it'll be ground is one of the middle ones. They're the black leads. And then we want to check pin 2, which is 5 volts. Oh, sorry, I'm in continuity mode here as well. So we don't have a short between ground and 5, which is good. 12. Ooh, yeah, so we've got, oh, you can't see. We have 8 ohms there, so that's not good. What about negative 12? That one's okay. And then let's go down to the other 5 volt rails. 200, that's fine. 200 and 200, yeah, so they're all fine. And let's just double check power good as well. No, nothing at all. So yeah, looks like we do have a short on our 12 volt line. So first of all, let's just get that guy out and see if that is, you know, if it quacks like a duck. It's obviously a blown tantalum. Let's get rid of it. Nope, there we go. Fallen. Okay. Let's check that again. Alrighty. Go back in. Between 12 and ground. No, still shorted. Interesting. So there must be another short somewhere else. So. That's going to be fun to track down. Let's take a good look at that tant as well. So, yeah, nice and splody. And it was a 16 volt 10 microfarad, which is good because I recently got a bag of those for replacing the exploded tantalum in my Compact Portable 3. So that's a good sign. Okay, so we took that tant out, It was obviously exploded, but the problem persists. Well, not the problem, but the short, I should say, that 8 ohm on the 12 volt line persists. So that pissed me off a little, and I just I did a bit of a desk clean to clear my head while I thought of the next move. So what I want to do is actually check if that tantalum was on the 12 volt line, because I didn't do that before. So let's go to continuity mode here again, and now I want to check the middle pin, because on a 3-line tantalum like this, the middle pin is the positive on the tantalum, and the 2 outer pins are a common ground. So what we should be able to see is that middle pin going to the 12 volt line, which we do. Okay, and then where's the outer line? The outer is going to negative 12. That's so interesting. Ah, wait, hang on. Okay, so we've got the middle line is going to both 12 volts and ground. So I expected it to go to ground because it's a negative line. So you want, if you've got a regular tantalum, the positive line will go to the more negative side of the negative rail, which in this case is ground, and then the minus 12 volt line will go to where the ground on the regular tantalum would be. Hope that makes sense. I might draw a drawing to make more sense. So the middle pin here I would expect to be on ground if this is the negative 12 volt line, which it seems to be, because the outer pin here does indeed go to the negative 12 line. But the middle pin is also going to... Oh yeah, of course, because we've got a short. My brain is fried. So we still have a short between 12 volts and ground, and that tantalum that we took out was for the negative 12 line. That was a lot of word salad to get there, but we got there. So now let's check some of the other tents. So let's go around the board. So this one here, let's check the middle. That's 12. And it's also shorted to ground. This one here is not 12. Well, it looks like it was. No, it's not. What are you? Ah, you are 5 volts. Okay. This one, let's go this side. That's also 5. That's also 5. And that one, I might just hold the 5 here because I expect all these ones down the bottom here to also be 5. Yep. 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 And yep. This one, yep. And this one, yep. And, oh, I missed that one. So, I mean, I'm pretty sure this is going to be the shorted one because everything else on the board is 5 volts. So, we've got 2 suspects. Is this one here or this one here? And let's go to 12 there. Ground and 12. Yeah, okay, so it's either one of these 2. So let's go to regular ohms mode and check between these 2 pins. And we are seeing a decent milliohms rating, which should be that capacitor having charged and is now discharging. And if we go between ground and this one, we get a dead short, 0.4. So that's our culprit. I will rip that out, and then let's pop in a new tantalum here and a new tantalum here, and see what happens. Let's check if we've lost that short. So should be able to go to continuity mode here. Oh, my leads are tangled. There we go. All right. So let's check between 12 and ground. Yes, no more shorts. So we should also now see no continuity between 12 volts and the middle pin on any of these 5 ones, which we saw before. Yep. So great. And let's check. Actually, no, let's do nothing. I reckon we're good to test now. Okay, there was our IBM power supply that we just proved was working. So let's pop that there, plug it in, Oh boy. Let's stand at a distance, turn it on, and see if anything else explodes. If I'm recording. Alright. Here goes. Whee! Yup. That was loud. That was the negative rail. Maybe I got that backwards. Oh, hey. Oh dear. Oh, that was slightly deafening. Alright. Talk about carnage. Look at that. I wonder if some of you watching this are yelling at the screen when I was doing that. I must have done that wrong. Did I do that wrong? Doesn't seem like I did that wrong. Yet here we are. Yep, no, I am an idiot. What I said holds true, generally, that with one of these 3 pins, you would match the positive with the positive and the negative with the negative. But I forgot to actually check how this one is set up. So that middle pin is ground, and the outside pin is more negative at -12. So, in this case, you want the tantalum in the same, same setup. Whoops. Oh well, we got some fireworks out of it. So that'll go in the same setup as the other side, with the positive lead of the new tantalum in the middle, which is the more positive rail of this particular setup. Got my safety squints on. Let's hit power and go. Hey, okay. Nothing exploded. Perfect. So, whew, now what? You know what I could do? I have the original MDA card here. So what I could probably do is hook that up to my, oh dear, RGB to HDMI, which should go on the connection right there, and just see if we get a signal out of this thing. So, I'll hook that up. We should be good to go. So, let's hit power. No. Interesting. Do we have power? Ah, okay. Now we have power. Oh god. Apparently we didn't have power in that last test, so I'm going to unplug all this, step back again, and check it with power this time. Okay. Now the power supply is turning on. And staying on, which is a fantastic sign. It means we've got enough load. So let's try it with the original MDA. Graphics card hooked up to my RGB to HDMI. See what we get. Ooh. Nothing good. That's interesting. The RGB to HDMI is not happy. How interesting. Oh, let's restart that. No, the RGB to HDMI is not happy. It is in PC CGA MDA mode, so it should be fine, but we're getting absolutely nothing, so something else is afoot. Okay, I've tried a couple of things, I can't get anything going, but as a diagnostics method, I thought I'd grab the speaker, see if it's beeping at me. So, that, you can't see, but that goes in down here, and it is keyed, so there's a little plug in the thingy there, so it can only go in the one way, which is that way. Alright, let's turn it on and see if we get a beep. How interesting. Well, I think I'm going to have to go and do a little bit more research, because I am stumped.